So as we are studying interference, we start with principle of superposition of waves. Now this we have already studied in mechanical waves, in sound waves, okay? But still, we need to know this. What is principle of superposition of waves? When two or more waves traveling in a medium arrive at a point simultaneously, the resultant displacement at that point is given by the vector sum of displacements produced by each wave individually, irrespective of others. Right? Now, this is called superposition of waves, and we have used this superposition, principle of superposition, waves के लिए भी use किया already, as well as हमने use किया है principle of superposition of forces electrostatics में and gravitation में. So this thing is very common, and we know that. Okay, then we'll try to define what is interference. Okay, interference of light, of course. Let's try to define. Okay, एक काम करते हैं, पहले सिर्फ interference term को define कर लेते हैं. Interference. So what do you mean by interference? So when superposition takes place, due to superposition of waves, the energy distribution in space and time of resulting wave varies. This phenomenon of change in energy distribution due to superposition of waves is called interference. Now we have already studied these definitions, but again, now in case of light, what will happen? In case of light, what will happen? As light, okay, according to wave theory of light, light propagates in the form of waves, right? Now we consider them to be electromagnetic transfers, right? Thus, when two or more light waves superpose on each other, now when two or more light waves superpose on each other, what happens? The resulting wave has different intensity patterns due to interference. So what you will see is the interference pattern shows variation of intensity, okay, in space, right, and slash or time. In space time means at given place or at given time, you can see different intensity patterns depending upon what kind of waves you have, what is their original condition, what are their speeds, etc., etc. So this is what we see. Okay, now let's move to the next thing. Then we actually define two types of interference patterns. One is called constructive interference. Now what is constructive interference? And we know it, हमने पहले भी define किया है. So when the amplitude of resultant of interfering waves become maximum, the interference is called constructive interference. Okay. Now, in case of light waves, the intensity of light becomes maximum. So what I've shown is, just imagine two waves. Time being, I'm showing identical waves. If they are superimposed, means just वो नीचे का wave ऊपर वाले wave के ऊपर exactly ऊपर अगर आप match कर दो, then you will see that the resultant amplitude is going to be very large. Now, ये कब हो सकता है ऐसा? When this can happen? So for the sake of understanding, I'll again draw the diagram roughly. Say suppose I cannot show it on one line. So what I'm doing is I'm drawing two lines. Suppose a wave travels like this. Actually, it has to be a straight line on single line, but that I cannot show. Say crest, trough, crest, trough, crest, trough, crest, trough. This is the way your wave is coming to this point. If there is another wave which is of the same frequency, just assume that. Now it reaches that point like this only. So now this is end point of a trough or starting point of a crest, and this is also end point of a, for green one also it is end point of a trough or starting point of crest. Now when this particle experiences this superposition, what happens? It will be crest on crest kind of thing for the next particle. So the amplitude becomes large. Now for this, what has to happen? If this wave ends here, wave means this wave ends here into end point of a trough, then whichever next wave, wherever it comes from, has to end like in the same way. Now this is possible if and only if we are assuming the same waves, okay? Then when that can happen, the path difference means the distance traveled by one wave minus distance traveled by other wave should be n times lambda, mod of that distance. Path difference is the distance traveled by first wave minus distance traveled by second wave. उसके बीच का जो distance है, that should be n times lambda, then that happens. And path difference and phase difference, they have a relation. So phase difference is equal to 2 pi upon lambda times path difference. Hence it is 2 pi upon lambda times n lambda. Hence it is 2n pi. So if you could satisfy any one of these two conditions, of course, one satisfied, then other one is always satisfied, and you will get constructive interference. And you'll get constructive interference here. Okay. Similarly, we have done this already, so I'm just revising. Next type of interference is destructive interference. Now, when this takes place, destructive interference किसे बोलेंगे? So when the amplitude of the resultant of interfering waves become minimum, right? The interference is called destructive interference. In case of light waves, the intensity of light becomes minimum. Okay. Now ये कब होगा? तो वेव को उल्टा होना चाहिए एक्चुअली. उल्टा यानी एक वेव का क्रेस्ट तो दूसरे का ट्रफ. It has to be in that situation. Then this will happen. Okay. एक का क्रेस्ट और दूसरे का ट्रफ, एंड फॉर दिस टू हैपन एक वेव हमेशा आधे वेवलेंथ जितना आगे होना चाहिए. That makes it odd multiple of lambda by 2. Okay. So condition for destructive interference in this case. What is the condition for destructive interference? So the condition looks like this. Path difference is the distance traveled by, well, separation between the two waves. This difference between the distances traveled by the two waves. Path difference delta x is 2n plus 1 lambda by 2. That makes it, if n is equal to 1, then it becomes 3 lambda by 2. Okay. Sorry, 0 से start करोगे तो it becomes lambda by 2. 1 से start करोगे तो 3 lambda by 2, and so on. And then you can correspondingly find out the phase difference. Okay. You can correspondingly find out the phase difference. Phase difference delta is 2 pi by lambda times path difference. So it becomes 2n plus 1 pi. And when you make it 2n plus 1 pi, it becomes odd multiple of pi. Okay. This is actually even multiple of pi. I can just mention it. This is even multiple of pi, while that one is odd multiple of pi. This one is odd multiple of pi. And then I'll just mention this part also. Note what is path difference. So to avoid confusion, because we have done these things already, but still, the difference between the distance traveled by the interfering waves from the source to the common point where they reach simultaneously is called path difference, denoted by delta x. So I'll prefer to denote it by delta x. I'll always denote it by delta x. And these are the conditions for interference. Okay. So now you just note down the conditions at least, and just do one thing. You can reduce the size of the diagram a bit. At least note down the conditions. We need those conditions. Based on that, our further analysis is based on these conditions. Right. So now, after knowing this, let's try to find out amplitude and intensity of resultant wave. Okay, for interference of light, of course. Huh? So what we do, we consider two planar waves and they travel along. We have done this analysis already in that chapter, तो वो मैं directly use कर रहा हूँ. So resultant amplitude A and intensity I of interfering waves, okay, is to be calculated. Then उसके लिए आपको वो इक्वेशन लिखना होता है, आपको शायद याद होगा. We have done this before. मैं आपको दिखाता हूँ कहाँ पे किया होता है हमने ये सब. This is where is waves and sound, and here in waves and sound we actually analyze the things जिसमें हम वो SHM की तरह ऐड करते हैं, या और इन SHM हमने ऐड किया होगा वो A1 square plus A2 square plus 2A1 A2 cos of alpha 1 minus alpha 2, right? So that I'm talking about that part. So ये सब जो वेव साइन इक्वेशंस ऐड करने की बात कर रहा हूँ मैं. तो द सेम थिंग वी आर डूइंग राइट नाउ. वी आर डूइंग द सेम थिंग. ओके, साइन इक्वेशन को ऐड करने की बात कर रहे हैं हम. सो इफ यू ऐड दैट दोस थिंग्स एंड if we come to this result, then resultant is given by, say, resultant amplitude A and intensity I of interfering waves हम calculate करना चाहते हैं. So let A1 and A2 be the amplitudes of two interfering waves and I1 and I2 be their intensities respectively. Then of course यहाँ पे वो ध्यान रखना, these are planar waves traveling along the same line of action. We are also assuming that having आपको याद होगा सेम फ्रीक्वेंसी भी होता है. So that is what we assume. That is where we started. Okay. So if these are the two things, then amplitude is given by A is equal to root of A1 square plus A2 square plus 2A1 A2 cos of delta, where cos delta directly phase difference लिखा है मैंने. Okay. Now for constructive interference, if you go for it, एक काम करूँ क्या, इंटेंसिटी का भी फॉर्मूला लिख के रखता हूँ. The resultant intensity is given by, what is the resultant intensity? इंटेंसिटी का फॉर्मूला क्या होता है? तो इंटेंसिटी इज डायरेक्टली प्रोपोर्शनल से we know that the intensity of light is directly proportional to, it is directly proportional to what? To the square of the amplitude of light wave. Okay, so therefore आपके पास क्या होगा? Therefore I is proportional to A squared, right? Now since this is true, then आप वो ऊपर वाले इक्वेशन को क्या लिख सकते हैं? ऊपर वाले इक्वेशन को आप लिखो, you can just make some changes now. As we know, this A हम इसकी बात कर रहे हैं. This A is this, right? Therefore square both sides and you write A is equal to, what is A? It is A1 square, correct, plus A2 square, A1 square plus A2 square plus 2 A1 A2 cos delta, right? If I just simply write it like this, therefore I is equal to K times A square, where K is constant, some constant of proportionality, right? Then multiplying both sides by K. Okay, so I can write therefore K A square, ये A square होना चाहिए, K A square is equal to, therefore K A square is equal to, what it will be? What it will be? K A square is equal to K A1 square plus K A2 square plus 2K, ये K होना चाहिए, right? Now if you do this, then from 1 and 2, what we can do? You can call it 1. You can call it 1 and you can call this 2. So from 1 and 2, what mathematical conclusion we get?
I square equals to
It becomes
I
I
equals
square
to
is equal
I1.
to I1 square plus I2 square plus वो एक तीसरा टर्म खाली important है. What do we get here? We can directly write I. This is I, not I1 square now, because I is K square. So this becomes I is equal to I1, right? Plus I2 plus, now that thing becomes 2 and root K A1, root K A2, that becomes 2 times root of I1 and I2. Definitely I2 will also be in root cos delta. So this is the way we get intensity expression. Okay. So this expression gives us intensity of resulting wave under the given condition. So the above expression gives the intensity of the resulting wave. Okay. What we have considered, only two waves are considered, only two waves. Okay. Okay. जरा इसे note down करो and then we'll proceed to the other part. Note down this. So for constructive interference, since delta is equal to 2n pi, what we can do is we can substitute it in the formula for amplitude. So therefore amplitude A is root of a1 square plus a2 square plus 2a1 a2 cos of 2n pi. N belongs to whole number. This is the condition. Now if n belongs to whole number, then cos of 2n pi is always 1. Okay. You can check that. Cos of 2n pi is 1, positive 1, as long as n belongs to whole number. So as long as this n belongs to whole number, set of whole numbers, then we have this condition. So what is this now? What is this now? So this is perfect square है वो actually under bracket root के अंदर. That is a1 plus a2 the whole square. Then a is simply mod of a1 plus a2. Minus sign तो नहीं देना है. Okay. And if a1 is equal to a2 in this case now, then what happens? If a1 is equal to a2 is equal to say a naught, then amplitude a becomes 2a naught. So resultant amplitude means if you have identical waves, then the result identical in this case, this aspect also, and unka amplitude be same hai, then you will get double the amplitude. Now can we find out intensity? This is the amplitude. This is the equation for amplitude. Okay, this is the equation for amplitude. Can we find out intensity? So intensity के लिए now do one simple thing. Do one simple thing. Intensity चाहिए ना हमें, तो intensity के लिए क्या करेंगे? वो formula same है ना, intensity का भी similar ही है. So just put this delta in that formula. Delta तो हमें पता है. Delta तो हमें पता है पहले से. So for constructive interference, what is delta? We know that delta is this. Okay. So ये इसमें substitution कर लो, right? So what do we get if we substitute it there? This changes to 2n pi. This cos delta again changes to 2n pi, and with that n belongs to whole number. It's that kind of thing, right? Not it's n. Then now if we know this, then again this becomes a square, but a different type of square. So we can write this as ये square ही actually अभी भी this I लेफ्ट हैंड साइड भी स्क्वायर है. इट कैन बी रिटन लाइक दिस, और ये डेल्टा की जगह पे आप ये लिखो. करेक्ट. सो व्हाट इज दिस नाउ? देन दिस बिकम्स राइट. इज इट राइट? तो रूट का स्क्वायर है पूरा. इंटेंसिटी. ओके. एंड then if they are the same, means if intensity of first wave is equal to intensity of second wave is equal to some I naught, then I is equal to I naught root I naught plus root I naught the whole square makes it 4 times I naught. So intensity is not simply added. When constructive interference takes place, intensity is not simply added like regular addition. Basically, it is something like vector addition of amplitude. So the resultant intensity is 4 times I naught. Okay, it is not 2 times I naught. So for constructive interference, we get these two conditions, means this condition. Now let's come to destructive interference. Now what is destructive interference? What is destructive interference? So for destructive interference, what do we have? For destructive interference, what is the condition? Delta is equal to 2n plus 1 pi. It is odd multiple of pi. So if you go for amplitude, this is amplitude. So what will happen? Now can you take pen, paper and try to solve this? If you want amplitude of resultant wave, what will get?
Cos 2n plus 1 0.
Cos 2n plus 1.
0 like.
So यहाँ पे 0 डाल देंगे आप, cos 2n plus 1. राइट. इज इट 0? मुझे नहीं लगता है 0 आएगा वो. ट्राई दैट. कितना आएगा? 2n plus 1. इट इज ऑड मल्टीपल ना. सो इट विल बी -1. 0 नहीं आएगा वो, -1 आएगा. कितना आएगा? -1 आएगा. 2n plus 1 is odd multiple, right? The cos of 2n plus 1 is odd, na? Odd multiple of pi. So that is -1. It is like cos 180. Cos 180 is -1. So it is that kind of thing. So therefore this becomes वो माइनस वाला स्क्वायर है. परफेक्ट. अगर आप इसे समझते हैं तो इट इज a1 minus a2 the whole square. So it is mod of a1 minus a2. Right? Then if they are the same, amplitudes are the same, then our answer is 0. So if you have that kind of waves, then you can actually get 0. Then intensity of resulting wave intensity. Now it can, I'm just directly writing it. Intensity will also be 0 if they are the same, and otherwise it is root of I1 minus root of I2 the whole square. Right? For destructive interference. So these are the conditions for constructive and destructive interference and resultant values of the resultant. Okay. Now there is something very interesting called Young's double slit experiment. Okay. Now in this Young's double slit experiment, we use, this is called Young's double slit experiment, mostly abbreviated as YDSE in our books. Okay. Now what we have here, so we use two long parallel slits, okay, as source of light. Fine. And the light coming out of the two slits, basically, see, let's, before we go for this, let's do one thing. Interference of light waves coming from two coherent sources. Now, do you know what is this word coherent means? Coherent sources. Coherent sources का मतलब क्या होता है? The phase difference between the waves emitted by the two sources reaching the given point remains constant in time. So that phase difference should not vary. Then such sources are called coherent sources. Now, in general, we obtain coherent sources by various methods. Okay. Coherent sources can be obtained by different methods in practice. Okay. In general, they are derived from a single source. In general, they are derived from a single source. So how do we do this experiment? Now, I'll show you what do we do. Say consider a pinhole. Pinhole समझ में आता है ना क्या होता है? It's a very small hole. So consider something like this. एक मिनट अभी मुझे diagram draw करना पड़ेगा. So I need this level. Say consider a cardboard placed like this. Okay. And you make a pinhole here at some point. Now that is your pinhole. Okay. And you simply place a source of light. Let's consider this as source of light. Let's consider this as source of light. And what will happen? This source, what I've done is I'm placing the source right in front of this. मतलब वो मैंने उसको बीच में रख दिया. I'm just trying to explain you first. Then we'll come to the actual experiment. So the rays of light अगर ऐसे देखोगे आप तो वो तो ऐसे travel करना चाहिए. This is going through the pinhole. I placed the source behind that. Then इसमें तो बहुत सारे रेज होने चाहिए. इनफैक्ट ये तो ऐसा दिखना चाहिए मुझे. It is a spherical wavefront, correct? And I hope you know what is spherical wavefront, what is cylindrical wavefront. That comes in the previous part of the chapter. Are you aware of that?
No, sir.
Do you know what is spherical wavefront? No. Now see, okay, anyway, even if you are not aware, let me just explain you what is spherical wavefront. See, if you take a point source like this, the way I've drawn it right now, if you take a point source, it's just a point in space. Okay. Now, this source will emit. Now, this was that Eugene or Huygens, however you pronounce it as, that wave theory of light, the original wave theory of light. Now, that fellow told us that if you have a point source of light, it will emit light waves in all possible directions. So, if you take some distance d, source say distance d. Now, since the source is a point, it is emitting light waves in all possible directions. What will happen? If you draw a sphere, keeping that source S at center, if you draw a sphere, then entire sphere will receive the light simultaneously because speed of light in that medium is constant. So all the points on that sphere, they will receive the light simultaneously. Since you are having a single source producing the light disturbance at the same instant, all these particles are in same state of vibration that we call phase. So they are in same phase. Such a surface, all the points of which receive the light disturbance simultaneously and hence vibrating in same phase, is called wavefront. Okay, such a surface is called wavefront. And if you draw perpendicular to that surface in the direction of propagation of light, then we call it wave normal. this wave normal is this line now, because it has to be perpendicular to the surface and it's a sphere, then radius is perpendicular to sphere. And this is called the wave normal, and wave normal is nothing but ray of light, जिसे आप कहते हैं, हमारे normal language में उसको ray of light बोलते हैं. So there will be many rays of light like this. There will be many. They will come out of this source and they will go in all possible directions. So these are rays of light. While the red colored sphere that I have shown, of course मैं इसको sphere नहीं दिखाना चाहता हूँ, पीछे की तरफ उसका कुछ वैसे तो काम नहीं है. So I can show only this part of the sphere. So the red colored part of the sphere is your wave front, and it is what type of wave front? So it is part of the sphere, so we call it spherical wave front. हम क्या बोलेंगे इसे? Spherical wave front. Now this happens when you use a point source, but instead of point source, if you use a slit यानी एक कट किया पेपर में ऐसा वर्टिकल कट, मतलब लंबा कट, एकदम पतला बट लंबा, then what will happen? देन उसके ऊपर वाले एंड से तो लाइट, ट्यूबलाइट जैसा इमेजिन करो, ट्यूबलाइट होता था ना पहले, अभी तो एलईडीज आते हैं, बट ट्यूबलाइट, समथिंग दैट इज ट्यूब लाइक शेप. तो उसके सरफेस में से ऐसा सिलिंड्रिकल वेव फ्रंट बनता है, because all the points at given distance they will receive the light disturbance simultaneously, they will form a cylinder. A coaxial cylinder is formed. Next step, bigger coaxial cylinder is formed. So this is how light propagates. तो ये थियरी है. Now this comes to this point. अभी इसके बाद this point itself, it behaves like secondary source of light and this emits light waves. तो अभी एक्सपेरिमेंट करने के लिए हम क्या करेंगे ना, इसके साथ इसके आगे, अभी ये है सोर्स, ये आपका एक स्लिट है. नाउ दिस विल एमिट लाइट. मैं जानबूझ के कलर्स चेंज कर रहा हूं इसके, सो दैट आई कैन शो यू व्हाट्स गोइंग ऑन. सो नेक्स्ट व्हाट आई एम डूइंग, दिस विल आल्सो एमिट स्फेरिकल वेव. सो अभी ये इसके सेंटर से होना चाहिए. एंड these wavelets are not effective in backward direction. So इसको backward direction वाला पार्ट तो मैं डिलीट कर रहा हूँ. I'm just showing the forward direction. Okay, that is the actual wave theory of light. So अभी ये कैसे होगा, एक इंस्टेंट पे आपको यहाँ पे दिखेगा. Suppose this solid line represents the crest and a dotted line represents a trough. Okay, so if we do it like this, another dotted line, another dotted line. So alternate crests and trough ऐसे प्रोड्यूस होना चाहिए यहाँ पे. Okay, then the next one will be again a solid line. This is what is going to happen. Alternate, अभी ये dotted line, just imagine it like crest and trough जो alternately आपको दिखता है. तो we are talking about a wave. So ये कुछ ऐसे दिखेगा आपको. So here we have a crest, a trough, then again a crest at same distance. So I can just I'll just try to draw that thing if possible. Let's check. So the separation should remain the same and it has to be a sphere, still a sphere. So something like this. You don't try to draw these things. I'm just trying to explain you using this diagram. And of course, it's better. So this is your next thing that becomes your crest again. So the wave goes like this, crest tough करके आगे जाएगा. And here are the rays. अभी ये ray सीधा जाना चाहिए, right? Then there are rays like टेढ़ा मेढ़ा किसी एंगल पे. तो आप तो बहुत सारे रेज बना सकते हैं. इट डजंट मैटर कि आप कहाँ पे कितने रेज बनाते हो. एक यहाँ पे, then there might be a ray over here in this direction, right? Similarly on the other direction also you can keep on doing that. This is the ray. So it is ultimately going to form a sphere. क्योंकि आप छोटा सा एक, what are you using? A small pinhole is being used. वो आपके कार्डबोर्ड पे आपने पिनहोल बनाया हुआ है. पिनहोल स्फेरिकल वेव फ्रंट प्रोड्यूस करेगा, तो ये स्फीयर जैसा आगे बढ़ेगा, यानी इट विल कीप ऑन फॉर्मिंग स्फीयर्स. ओके, आप अभी एक काम करो, इसके आगे, इसके सामने, एग्जैक्टली इसके सामने आप और एक कार्डबोर्ड खड़ा कर दो यहाँ पे. द मोमेंट यू डू दैट, दीज रेज कैन नॉट पास थ्रू इट. ओके, ये जो रेज मैंने दिखा है ये तो इसमें से पास नहीं हो सकते. सो वी कैन जस्ट, ये तो इसमें से पास नहीं हो सकता. अभी मैंने कार्डबोर्ड रख दिया सामने. But what will happen, ये कंटिन्यूटी में है, इसके आगे बढ़ते जाएगा ये, तो वो पास नहीं होने वाला पार्ट छोड़ दो. नाउ व्हाट यू डू, you make two more pinholes. Now what will happen? Now what will happen? If you make two more pinholes, then अभी ये एक सोर्स था जो तो कोई भी था, इससे एक सोर्स से आपने एक परफेक्ट स्फेरिकल वेव बना लिया. नाउ इन दैट स्फेरिकल वेव फ्रंट, ये जब यहाँ पे पहुंचेंगे तो यहाँ पे दिस विल अगेन एक्ट एज सेकेंडरी सोर्स, और यही एक्शन फिर से होना चाहिए. Now when the same action takes place, now I am purposely using two different colors. Okay, even though light का कलर कोई चेंज नहीं होने वाला है, मैं आपको एक्सप्लेन करने के लिए यूज करके दिखा रहा हूँ. So suppose this forms after some time, ये crest का position है, ऐसे इमेजिन कर लो आप. This is the position of crest. Okay, this is the position of crest. Then उतना ही डिस्टेंस दूसरे का क्रेस्ट भी ट्रेवल करेगा ना, दूसरा जो भी होगा, तो दूसरे का क्रेस्ट भी उतना ही डिस्टेंस ट्रेवल करेगा. आई नीड टू चेंज द कलर, इसका कलर ये पर्पल कर देते हैं, होपफुली वो दिखे. हाँ, तो ये दूसरा जो है वो भी उतना ही क्रेस्ट प्रोड्यूस करेगा, बिकॉज दैट इज ऑल्सो द सेम थिंग. सो ये अगर क्रेस्ट प्रोड्यूस करेगा तो नाउ व्हाट विल हैपन, अभी ये दोनों क्रेस्ट यहां तक पहुंचे. देन आफ्टर सम टाइम, इसका ये बैकवर्ड डायरेक्शन वैसे तो काम का नहीं होता है, तो यू कैन बेसिकली डिलीट इट इफ यू डोंट वांट दैट. एक्चुअली डॉटेड लाइन दिखाते हैं डायग्राम्स में. इफ यू व्हेन वी स्टडी वेव थियरी, फिर से अगर मुझे लगा आपका वो हो गया, बट इट इज ओके, दिस पार्ट कैन बी अंडरस्टूड विदाउट दैट ऑल्सो. अभी इसके आगे जाने पर क्या होगा, थोड़ी टाइम बाद ना, नेक्स्ट. सो एक क्रेस्ट एक ट्रफ, मतलब आप इसको अगर देखते जा रहे हो तो ऑल्टरनेट आपको क्रेस्ट एंड ट्रफ दिखते जा रहे हैं. सो सपोज आई एम नॉट शोइंग ट्रफ, आई एम शोइंग ओनली क्रेस्ट. उसके बीच में ट्रफ होना चाहिए, या ट्रफ भी दिखा दो. एक्चुअली ट्रफ दिखाना चाहिए, बट इट इज वेरी डिफिकल्ट फॉर मी टू ड्रॉ. वो पेपर पे आसानी से काम होता है या बोर्ड पे, यहाँ पे थोड़ा सा डिफिकल्ट काम है. ओके, सपोज दिस इज योर ट्रफ. देन let's draw the trough here. So this is the trough for the second one. Now if you look at this, you will see something very interesting happening. Okay, if you continue to do this crest trough ऐसे करते जाओ, of course इसके पीछे वाला पार्ट जो हमारे काम का नहीं है ना, I'll just keep on deleting that so that will not get confused with that part. ये पार्ट तो हमारे काम का नहीं है, वो उस स्लिट के पीछे है. Now if you look at this, and this is being the trough, this thing is being the trough. Okay, that thing being crest and this thing being trough. ये दूसरा वाला जो लाइन है वो trough है. तो तीसरा वाला लाइन equally spaced I need to draw again, representing the crest again. If you look at this, what is happening here at this point, और एक draw करो तो ज्यादा अच्छे से दिखेगा आपको. If I'll draw one more, and if it has the okay, let me draw one more, and if it has the same spacing, then everything looks perfect. अगर सेम स्पेसिंग पे आप ड्रॉ कर पाए तो, एक्चुअली राउंडर लेके आप काम करते हो तो आसान होता है. यहाँ पे मेरे पास राउंडर नहीं है, और यहाँ पे कोई सेंटर होल्ड करने का तरीका नहीं है. सो वी लुक एट दिस, इट विल लुक समवॉट लाइक दिस. ओके, ऐसा कुछ. तो नाउ इफ दिस थर्ड वन इज अ क्रेस्ट, if this third one you are drawn is a crest. Okay, so now look at this, what happens here, what is happening here. ये जो बीच के पॉइंट्स है ना, अभी मैं पॉइंट्स को ब्लैक कलर से ही मार्क करूँ या रेड कलर से मार्क कर देता हूँ. आई एम मार्किंग दोस पॉइंट्स विद रेड. ओके, इफ वी स्टार्ट मार्किंग दिस पॉइंट्स विद रेड, लुक एट दिस पॉइंट. ये क्या है, क्रेस्ट ऑन क्रेस्ट, ट्रफ ऑन ट्रफ. ये ट्रफ ऑन ट्रफ है, ये क्रेस्ट ऑन क्रेस्ट है, राइट. अगला पॉइंट क्या आएगा, ट्रफ ऑन ट्रफ आ जाएगा. उसके अगला पॉइंट फिर से क्रेस्ट ऑन क्रेस्ट आ जाएगा, राइट. सो इफ आई फॉलो दिस लाइन, और सामने अगर मैं स्क्रीन रख दूं यहाँ पे, इफ आई प्लेस अ स्क्रीन ओवर हियर, by following those points, if I place a screen over here, then what do I see on screen, what do I see on screen along that path. तो यहाँ पे ना मुझे सारे क्रेस्ट ऑन क्रेस्ट, ट्रफ ऑन ट्रफ आते हैं, तो इस पॉइंट पे कुछ भी करके क्रेस्ट ऑन क्रेस्ट या ट्रफ ऑन ट्रफ आएगा. सो व्हाट आई विल सी हियर इज अ ब्राइट पॉइंट. क्या दिखेगा मुझे यहाँ पे, ब्राइट पॉइंट दिखेगा इस पॉइंट पे. देन इफ आई फॉलो दिस लाइन, ये पॉइंट को देखो, यहाँ पे ये क्रेस्ट था आपका, ये ट्रफ है, मतलब यहाँ से ये सेंटर से चलो, इस पॉइंट को देखते हैं. then what happens? What is here? This point is, and this point is. Do you see that? What are these points? These points are, those points are, ये ट्रफ और इसका क्रेस्ट है, और ये इसका ट्रफ और उसका क्रेस्ट है. So if you follow these lines, then if you follow those lines, then what you will see? अगर आप ऐसा उस लाइन पे चले जाते हो, इफ यू ड्रॉ दिस, ये ऐसा लाइन पास होने वाला, इसमें से यू विल फाइंड दैट कि ये जहां पे स्क्रीन पे हिट करेगा वहां पे ऑलवेज इधर क्रेस्ट ऑन ट्रफ और यू में से ट्रफ ऑन क्रेस्ट, ऐसा ही दिखेगा आपको ये पॉइंट्स. सो व्हाट विल बी देयर? तो देयर विल बी, अगर ये वेव्स एग्जैक्टली आइडेंटिकल है, तो डार्क के लिए मैं डी लिख रहा हूं और ब्राइट के लिए बी लिख रहा हूं, तो ये आपको डार्क दिखना चाहिए, हमेशा डार्क दिखना चाहिए. ये डार्क दिखेगा एंड ये ब्राइट दिखेगा, ये बीच का पॉइंट ब्राइट दिखेगा. अच्छा, बियॉन्ड दिस इफ आई कंटिन्यू टू फॉलो द सेम पैटर्न, देन अब आई कैन ड्रॉ अ लाइन जस्ट टू शो यू. ये सेंटर से ये दिख रहा है, ये पॉइंट, वो उसका, ये वाला पॉइंट, ये इसका जहां पे पोजीशन है ना, ये दो, वो फिर से ब्राइट लाइन बनाएंगे, ब्राइट पॉइंट बनाएंगे स्क्रीन पे. सो इफ यू गो हियर अलोंग दिस, ये जहां पे भी, अभी मेरा डायग्राम थोड़ा अजीब सा है तो वो स्क्रीन पे हिट नहीं कर रहा है, बट इफ यू गो विद दिस, दे विल गिव यू ब्राइट पॉइंट अगेन ऑन स्क्रीन. अच्छा, और थोड़ा बाहर जाओगे बियॉन्ड, देन दे विल गिव यू डार्क पॉइंट अगेन. सो व्हाट यू विल सी ऑन स्क्रीन, स्क्रीन पे क्या दिखेगा? सो इफ यू लुक एट द स्क्रीन, और अगर आप ये पिन होल लेके काम कर रहे हो, तो ऑन स्क्रीन यू विल सी, आई विल जस्ट ट्राई टू गेट द इमेज. I'll show you the image. What do we usually see? Looks somewhat like this. ये लेजर का पैटर्न है. ओके, ऑफ कोर्स नॉट एग्जैक्टली लाइक दिस, ये पैटर्न है, बट उसमें दो चीजें हैं, मतलब उसमें इंटरफियरेंस भी है और डिफ्रैक्शन भी है. सो इसका मुझे इमेज, आई कुड गेट दैट इमेज. It looks like circles basically, but I don't see any proper diagram for that. I don't see any image. They form concentric circles. Okay, so on screen what you will see is the pattern obtained on screen is, ये क्या होना चाहिए? Concentric circles, okay, of alternate bright concentric circles, alternate bright and dark. ऐसा पैटर्न दिखता है आपको स्क्रीन पे. So this is just a basic idea of what happens and how it interferes. ये सर्कल क्यों दिखेंगे, क्योंकि आपके वेव फ्रंट स्फेरिकल है, तो स्फीयर का क्रॉस सेक्शन करेंगे आप तो सर्कल दिखना चाहिए आपको. Okay, so now we'll come to YDSE, Young's double slit experiment. Now in Young's double slit experiment, what Thomas Young did is slightly different. What he did, instead of using spherical wavefronts, he used two long parallel slits, okay, as source in place of, अभी आपको मैंने background बता दिया. So in double slit experiment, we use two long parallel slits as source of light in place of pinholes. Okay. Now what happens? The light coming out of this slits is intercepted. Actually इसका भी डायग्राम ऐसा दिखता है. अभी आई विल शो द डायग्राम. तो डायग्राम देख के आपको पता चल जाएगा. ऊपर तो मैंने पूरा डायग्राम ड्रॉ करके दिया, ये दिखता है. So now we are using a plane wavefront first. Hits the source, hits the first slit. That will create a cylindrical wavefront, and that cylindrical wavefront hits the two slits, producing next two cylindrical wavefronts. तो स्क्रीन पे आपको ना इंटरफियरेंस इंस्टेड ऑफ अपियरिंग सर्कल ये ऐसा दिखता है. ये एक्चुअल इंटरफियरेंस पैटर्न का इमेज है. ये पूरा उसका करस्पॉन्डिंग इमेज ले लो आप इसे. तो ये इमेज है ना, ये दिख रहा है आपको ऑल्टरनेट डार्क एंड ब्राइट. अभी आप पूछ सकते हैं ये ऐसा क्यों. सो दिस इज बिकॉज ऑफ ओवरलैपिंग ऑफ दैट डिफ्रैक्शन पैटर्न ऑन इट. तो ये डिफ्रैक्शन का ओवरलैपिंग है, लेकिन इसके बीच का ये पैटर्न देखो. दिस इज व्हाट यू सी ऑन स्क्रीन. एग्जैक्टली दैट थिंग कैन बी सीन ऑन स्क्रीन. ठीक है. सो दिस इज योर एक्सपेरिमेंट, यंग्स एक्सपेरिमेंट. अभी जो मैंने एक्सप्लेनेशन किया इसमें मैं तो स्फेरिकल यूज कर रहा था, बट इन दिस पर्टिकुलर एक्सपेरिमेंट वी यूज दिस. तो ऑल्टरनेट ऐसा पैटर्न दिखता है हमें. ब्राइट एंड डार्क, उनको फ्रिंजेस बोलते हैं या बैंड्स बोलते हैं. ठीक है. ब्राइट एंड ऑल्टरनेट ब्राइट एंड डार्क बैंड्स और फ्रिंजेस. फाइन. नाउ we have to analyze this situation. So let's analyze it. How do we analyze this situation? Mathematical analysis कैसे करेंगे इस situation का? So YDSE analytical treatment. Okay. Let's analyze this analytical treatment. So to analyze this, we have various ways to do that. एक simple तरीका होता है जो कुछ ऐसे दिखता है. First you will draw the diagram. एक काम करो आप diagram draw कर लो. मैं डायग्राम ड्रॉ नहीं कर रहा हूँ. I'll just copy it. I'll tell you what are the things. Say our diagram starts with a slit. This is the slit. अभी मैंने ये शॉर्ट में ड्रॉ किया. This slit is placed on the perpendicular bisector of these two slits S1 and S2. कहाँ पे प्लेस किया है? On perpendicular bisector of S1 and S2. S1 and S2 are two other slits. Slits must be very thin, separated by distance d. Okay. अभी उसमें से दो वेव्स मैंने ड्रॉ किए, दो रेज ड्रॉ किए, एक S1 से एक S2 से, विच आर हिटिंग दिस पॉइंट O एट द सेंटर. फिर ये दो मैंने ड्रॉ करके रखे फॉर द रेफरेंस. ये परपेंडिकुलर है तो ये इसका डिस्टेंस MO इज d/2 एंड ON इज d/2. एंड दो रेज मैंने किसी एक ऑड पॉइंट P पे ड्रॉ किए. P इज एट डिस्टेंस x फ्रॉम दिस O एंड द सेपरेशन बिटवीन दीज टू, दैट स्लिट एंड स्क्रीन, इज कैपिटल D. जरा इसे ड्रॉ करो पहले एंड देन विल सी how to use these things and how to analyze the experiment. Do it fast. So in previous lecture, we have seen the YDSE arrangements, Young's double slit experiment arrangements, and we have drawn this diagram where here my assumptions are again, this is the experimental setup. So S1 and S2 are the two slits separated by distance D. So I can just write S1 and S2, two slits. Okay. S itself is source of monochromatic light. Okay. Then D is the separation, D is the distance between the two slits, right? Then capital D is the distance between the slits and the screen. So these are the things we have. Okay. And with this, diagram, we can proceed to analyze this situation. Now, how do we analyze this situation? Say at point O, what will happen? So at point O, which is definitely on the perpendicular bisector of S1, S2, okay, the light waves coming from both S1 and S2 will travel the same distance. So as the light waves coming from both S1 and S2 travels the same distance, equal distance, hence the path difference S2O minus S1O is 0. Now since this path difference is 0, what happens when path difference is 0? The point becomes bright. Now since there is a cylindrical wave, so at point O, waves interfere constructively, producing a bright point. Okay. Now since wavefronts produced by these slits are cylindrical, instead of getting single point, we get a bright fringe or bright band produced on screen as shown in previous diagram मैंने आपको दिखाया था. Okay. So this bright band is called central bright band or central bright fringe. ठीक है. Now let P be any point. Now let P be any point at distance X from point O. So P is any point on screen, of course. At distance X from point O. Okay. Then what will happen? Since the distance S2P is not equal to S1P, you can see that in the diagram. S2P is not equal to S1P. The light waves reach point P with path difference delta X, which is S2P minus S1P, and they will reach with path difference. Now to find this path difference, what we'll do? To find this path difference, we can use a simple geometrical method using Pythagoras theorem. So let's use that. Let's see how to do this. In triangle S2NP, keep on observing the triangle. In triangle S2NP, S2NP. Can you see triangle S2NP in the diagram? Yes. In triangle S2NP, I can write S2P square is equal to S2N square plus NP square. ये कहां से आया? Using क्या यूज किया? Using इसको क्या बोलते हैं? What it is called? अरे Pythagoras theorem, no? Right? This is called Pythagoras theorem. So using Pythagoras theorem, right? So this is what we have. S2P square is equal to SN square, S2N square plus NP square. And in triangle, दूसरा triangle ले लो, दूसरा triangle है. Now diagram, एक minute, just a minute. I'll just adjust it. Okay. So you can see the diagram now. So in the other triangle S1MP, of course, using Pythagoras theorem, we can write it up here. So we can use Pythagoras theorem in that triangle. So it is S1P square is equal to S1M square plus MP square. So now what do we have here? What we have here? The relation for S2P square and S1P square. उससे हमें S2P minus S1P ढूंढना है. तो what we'll do? Now subtracting equation 2 from equation 1. What we get? Subtracting equation 2 from equation 1, what we get? Yes, what we'll get here? What we'll get here? Subtracting equation 2 minus equation 1 kar lo. So if you do this, then we get S2P square minus S1P square is equal to S2N square plus NP square minus S1M square minus MP square. Subtract kar diya maine. ठीक है? Now once you do that, from figure, we can make out certain things. From figure, see this S2N, ये यहाँ पे S2N and S1M, both are D, right? You can just keep the diagram there. Let me try. Let's have the diagram here. Let's keep the diagram here just to check what are the values. Let's keep it here. Okay, now can you see that S2n, S2n and S1m is equal to D, and NP is equal to x plus D by 2, while MP is x minus D by 2. So if you get this, then we can substitute this in above equation. If I substitute these things in above equation, what do we get? We get, keep the left hand side same. S2p square minus S1p square is equal to D square plus x plus D by 2 the whole square minus D square minus x minus D by 2 the whole square. Now we get it like this. Simplify. Just simplify it. So therefore S2p square minus S1p square is equal to x square plus xd plus d square by 4 minus x square minus xd plus d square by 4. We keep on doing this algebra, and finally we end up getting this. So S2p square minus S1p square is equal to 2xd, and we can write it like this. S2p minus S1p into S2p plus S1p is equal to 2xd. Then S2p minus S1p, which is the part difference, is 2xd upon S2p minus S1p. You end at this point. Now, when you reach this point, we know that since path difference delta S is equal to, S2p minus S1p, we can always write delta x is equal to 2xd upon S2p plus S1p. Now, what is S2p plus S1p? Now, if x is very small compared to d, generally x is in few millimeters maximum, while d is in meters. So, since x is very small, that S2p and S1p, if you add them, the answer is almost equal to 2 times d. So, since S2p and S1, since x is very small, S2p is almost equal to S1p is almost equal to d. So we can write S2p minus S1p is equal to 2d. Substitute this thing in our expression, and we get delta x is equal to 2xd upon 2d. Hence delta x, the path difference, is x small d upon capital D. So that is how we get the path difference, which is x small d upon capital D. Now these steps are to be followed, right? For first central point, which is on the perpendicular bisector. In this particular case, this is 0, path difference is 0. For some point, the path difference is S2p minus S1p. With our analysis, we reach this point, delta x is equal to x d upon d. Okay, now go through this once. Once you are done, let me know. Diagram आपके पास पहले से है या फिर यहाँ पे भी है. ये diagram थोड़ा छोटा किया है मैंने, but still you can manage to get all the required things here. Okay, so just go through it, and then we'll proceed to the next part. There is another alternate method which we have. There is one more alternate method here which we can use to get that same answer. This method is much easier, but of course your board exam does not use this, board books do not use this method, but I prefer to use that one. See, if I could draw that diagram and enlarge it like this. Now I am drawing only that enlarged part. ये वो part है जो source की तरफ का part है. Okay. Then I have dropped a perpendicular from S1 to this line. Okay. So construct segment SQ perpendicular to segment S2P. If you construct that segment, then if angle PS1M, अभी ये diagram, of course ये इसके respect में वो enlarged diagram है, तो I'll just copy this one also and keep it there. Let's keep it there. ये इस diagram के respect में वो diagram है, so let's keep this here. तो इसको हम देख के बता सकते हैं वो क्या है. That diagram is just enlarged diagram of this same thing. इसका ही वो diagram है. Okay, so you can see PS1M, okay, is theta. That is what I have assumed now. PS1M is theta. Then in triangle S1QS2. S1QS2. Now you look at the left hand side diagram. Angle S2Q, S2, S1Q is almost theta. So we can use it as theta. We can do that small approximation. We have already done an approximation up there. So side S2Q is equal to delta X. That is the additional part. Side S1, S2 is D. And angle Q is equal to 90 degrees. Now, if you get these three things, then you can actually write what is sine theta. Right? Sine theta is equal to S2Q upon S1, S2 is equal to delta X upon D. Then delta X is equal to D sine theta. So we know what is delta X. Now, since theta is very small, okay, since theta is very small, sine theta is almost equal to theta. Now, as sine theta is almost equal to theta, you can write delta X is equal to D times theta. Okay. Now, from figure, if you know the basic definition of angle, then theta in radian is X by D. It is X divided by D. Okay, because this angle is also theta. So you can just substitute it there from equation 2 and 3. What we get? From equation 2 and 3, we get delta X is equal to X D by D. Okay. So delta X is equal to X D by D. This is alternate method. Here I am using trigonometry instead of using this kind of Pythagoras theorem. This lengthy method is there in your textbook. This method is not there, but you can always use this for calculation purpose. Now, after knowing this much, we know what is the path difference. Now, let's check if point P is bright or dark. So now, for point P to be bright point, so for P to be bright point, there must be constructive interference taking place at that point. Now, constructive interference takes place when path difference delta X is integral multiple of lambda. And we know this. If delta X is integral multiple of lambda, we have studied the conditions, then only it will be constructive interference. So if you write it like this, delta X is equal to X D upon capital D is equal to N lambda, then X is equal to N lambda small capital D upon small d. Right? It is N lambda capital D upon small d, because you are trying to satisfy this condition. Thus, the position of nth bright band from the central bright band, that is distance x, is given by xn is equal to n lambda capital D upon small d. ये part difference का उल्टा है, confuse मत होना. Okay. Now the separation between two successive bright bands, which is called bandwidth. Then can you find out what is bandwidth? So bandwidth is denoted by beta, and this beta is equal to n lambda d by d minus n minus 1 lambda capital D upon small d, which results in beta is equal to lambda capital D upon small d. Similarly, for point P to be dark point, destructive interference must take place. Now, for path difference delta X, destructive interference takes place when it is odd multiple of lambda by 2. So we can do that. Just compare. Now here I'm purposely not using n. Instead, I'm using m. And my n was a whole number. And here my m was. These are number representations. M is a natural number. So delta X is equal to X D upon D, which is 2m minus 1 lambda by 2. Just compare and we get X is equal to 2m minus 1 lambda capital D upon 2 times small d. Okay. Thus, the position of mth dark band from the central bright fringe. Central bright band can be considered as 0th bright band. So counting starts with 0 in that case. Hence, I am using n as natural number, but counting starts with 1 in this case. इसलिए मैंने m से start किया, which is a whole number. So xm dash is equal to 2m minus 1 lambda d by 2d. Again, the separation between two successive dark bands is also called bandwidth. And hence, if you try and calculate this, bandwidth remains the same. It is lambda d upon d. So now, if you try to find out what is the distance between one dark band and adjacent bright band, then it is lambda d upon.
Sir, your mic is off.
Okay, so the distance between the adjacent dark and bright band is lambda d by 2d. the alternate dark and bright bands observed on screen and their positions with respect to central bright band. So it looks like this. ये 4 I naught है, intensity maximum. Then sub bright band का intensity same 4 I naught है, and the position is 0 for central bright band. Then bright bands मैंने 1 B लिखा है, वो सारे bright bands है. तो फर्स्ट वाला, देन बीच में ये बीच का लाइन है वो ब्राइट बैंड है, दैट इज लैम्डा डी बाई डी. देन नेक्स्ट वाला जो है वो 2 लैम्डा डी बाई डी, उसके नेक्स्ट वाला है वो 3 लैम्डा डी बाई डी, नेक्स्ट वाला आएगा. ये पोजीशन की बात कर रहा हूँ, इसके लिए जो पोजीशन है. वाइल डार्क बैंड इज दिस डॉट्स, तो वो डार्क बैंड्स कहाँ पे होते हैं, तो इनके एग्जैक्ट बीच में. यू कैन सी इट इज बिटवीन लैम्डा डी बाई डी, इसके बीच में और इसके बीच में. सो दैट बिकम्स लैम्डा डी बाई 2D. Okay, so this is how we get the bands. Now if you want to find out what is the intensity of bands, so let's see what will be the intensity of bands. So iska intensity ke liye what we'll do to find intensity of bands, for interference we know that for interference pattern intensity I is equal to I1 plus I2 plus 2 root I1 I2 cos delta. Now in this case I1 is equal to I2 we already know because we are using the same intensity light. So thus the intensity of the resultant is given by this formula, I naught plus 2 root I naught cos delta, which can be then reduced to I naught 2 I is equal to 2 I naught in bracket 1 plus cos delta, which can be then written as I naught 2 I naught in bracket 2 cos square delta by 2. 1 plus cos delta is equal to 2 cos square delta by 2. And also delta का वैल्यू हमें पता है, delta is equal to 2 pi by lambda times delta x. So substituting this value in the above expression, we end up getting I is equal to, you can see that I is equal to 2 I naught in bracket 2 cos square 2 pi by lambda delta x by 2. Now, if you put delta x, which is x small d upon capital D, then the expression gets reduced to this kind of thing. This is what we have. Okay, by substituting that value, ये कुछ मिलेगा हमें, ऐसा वाला expression. Okay, we get it like this. Now what it shows, the above expression shows that वो cos square है, cos square, the intensity of interference pattern obtained on screen with distance from central bright band, okay, varies sinusoidally. Varies sinusoidally. Okay. दूसरा, the intensity of all bright bands is same and it is equal to 4 I naught, while intensity of all dark bands is 0. So that is what we get from this expression. Actually इसमें कैसे होता है, अगर आप for dark band, what is this, इसका वैल्यू होता है डार्क बैंड के लिए x d by d is, ये यहाँ पे आपने सब्स्टिट्यूट किया, x d by d is 2m minus 1 lambda by 2. This is what you are going to substitute. यानी for say अगर आप ये करते हो तो ये एक्सप्रेशन है, बट मैं इसके बाद लिखता हूँ substituting what we will substituting the path difference and we get for bright band substitute किया अगर आपने path difference for bright band क्या होता है path difference होता है in this formula we want to substitute. So here in this formula path difference is for bright band क्या होता है path difference is simply n lambda. Okay, so delta x is n lambda where n belongs to whole number, right? तो इसका आंसर क्या आएगा, this will be cos of 2n pi, correct? Now what is cos of 2n pi? Cos of 2n pi,
1.
cos of 2n pi is 1. So this will be 4 I naught then. This will be 4 I naught as cos of 2n pi आएगा या n pi आएगा, वो चेक कर लो आप. इसका पार्ट डिफरेंस मैंने एन लैम्डा सब्स्टिट्यूट किया, ये एन लैम्डा है, आई एम सब्स्टिट्यूटिंग एन लैम्डा ओवर हियर इन प्लेस ऑफ पार्ट डिफरेंस. So this becomes lambda will get cancelled 2n pi, so it is pi n हो जाएगा. Sorry, part difference is pi n pi, and n belongs to cos square of n pi is equal to 1 आएगा, ये +1 आएगा always. And for dark band, for bright band जैसे लिखा वैसे dark band का भी condition लिखो. What is the condition for dark band? For dark band, for dark band what is the condition? ये n lambda नहीं होता है ना dark band के लिए, वो क्या होता है 2m-1 है ये. This is the thing, right? So we'll write 2m-1 here. That is 2m-1 lambda by 2. So delta x is 2m-1 lambda by 2, and m belongs to, in that case, m belongs to natural numbers. That m belongs to natural numbers. Okay. So what are the values here? What are the values here? This will be cos square of, ये आंसर 0 तो हमें पता है पहले से, but it will be cos square of what? Cos square of what? So if you just write lambda will get cancelled, 2 will get cancelled, so it is pi by 2, and it will be odd multiple of pi by 2. So that is cos square of odd multiple of pi by 2 is 2m-1 pi by 2. This is what you will get, which is equal to 0. So the intensity of all bright bands is same, and it is equal to 4I0, while that for dark bands is 0. So this is the way we get, this is the way we analyze this particular thing called, this is called, इसको क्या बोलेंगे आप? This thing is called Young's double slit experiment, और उसका ये analytical treatment है with all the part differences. Okay, ठीक है. So now you go through this. Alternate method तो लिखने की जरूरत नहीं है. You go through this for dark and bright conditions, and once you are done, just let me know. Okay. So now there are certain conditions to obtain steady interference pattern. So you cannot always get steady interference pattern unless and until you don't satisfy these conditions. The first condition is the two sources of light must be coherent. Okay, coherent का meaning मैंने आपको पहले बता दिया है. The phase difference between the waves emitted by the two sources must remain constant in time. वरना क्या होगा उस जगह पे, if the phase difference varies in time, तो वो हर बार constructive destructive interference properly नहीं होगा. Then you cannot see a distinct pattern. Okay. The sources must be monochromatic. We'll discuss what happens when we use polychromatic source at later stage. Right now, they must be monochromatic. Just remember that. Monochromatic समझ में आता है ना, same wavelength. Okay. They must have same amplitude, so same intensity. The separation between the slits must be very small, क्योंकि वो small d देखो denominator में. So it has to be as small as possible. Okay. The distance between the slits, okay, must be large. That capital D must be large. Okay. The two slits must be as narrow as possible, because if the slit is wide, then it won't be like one source producing one wave. It will be like many infinite sources. उसके बीच में जितने भी sources होंगे, everything will act as a source. So then you won't get a distinctive pattern. Instead, you get a diffraction pattern overlapping on it, that thing. And the two interfering waves must be in same state of polarization. So same state of polarization means their plane of vibration must be same. So if you satisfy these conditions, then you can get steady interference pattern. Note, if the place of illuminated slit, if in place of illuminated slits, if you use 2-point sources, आपको बताया था मैंने last time we started with this, in YDSE, the interference pattern obtained on the screen is in the form of concentric bright and dark rings instead of getting fringes. Okay, so we'll stop here today. I'll send you all these things. Go through it once again. These derivations are important for your board exam also. They ask you to derive these things. So please make sure that you know how to write down these things. Okay, so we'll stop here. Next lecture, regular lecture Monday as per our timetable. So तब मिलते हैं and we'll continue with this.